Welcome to the course Exploring the Solar System. I am Shweta from Astronera, and in this lecture, let's travel in the past to understand how our solar system was born. Scientists have developed three different models to explain how planets in and out of the solar system may have formed. The core accretion model, the disk instability model, and the pebble acceleration model. According to the widely accepted core accretion model, the Sun was formed the way all the other stars do, from a nebula. Approximately 4.6 billion years ago, the solar system was a cloud of gas and dust. All the material in this solar nebula collapsed onto each other because of its gravity. Then it started spinning, which formed the Sun at the center of this nebula. A disk of gas and dust was still swirling around the Sun. The material in this disk started to clump together. Bound by the force of gravity, the small particles merged onto the larger particles. The lighter elements were swept away by the solar wind, and only the heavier, rocky material remained nearer to the Sun. This then led to the formation of the terrestrial planets, the first 4 planets in our solar system. The lighter elements such as hydrogen and helium, which swept away further from the Sun where the solar wind had less impact, then merged into the gas giant planets. The leftover particles in space then resulted into the formation of the moons of these planets, or asteroids and comets. How big was the disk from which the elements of our solar system were formed? How far does the gravitational force of the Sun reaches in the space? Let's find out in the next lecture.